So welcome to this video. We'll be using struct to define simple types. Let me just show you and then we'll dive in and get it done. We're going to make a thing here called struct bull cow count. And it's like a class, but it's even simpler, and it's a simple structure that can contain two integers in one go. So that we can write a method like this, bull cow count submit guess, taking in a string and returning a pair of integers. So let's get it done. Okay guys, welcome back. So we're going to do something fun in this video. We're going to implement our actual bull cow count. But before we can do that, we need to define a new data type. Because where we have said here in the header that we want to provide a method for counting bulls and cows and increasing the try number, we need bulls and cows to come back together in one go. And how are we going to organize that? Well, we're going to use something called a struct. Now, I must tell you that a struct is exactly the same as a class, basically, except for by default its members are public, and that lends itself to being ideal for simple data types like this. Let me show you. If we say struct bull cow count here, now I'm at the top of bullcowgame.h because this is a structure that we're not going to use in main CPP, but we are going to use inside our game logic. Okay, now I'm going to open up some brackets like that. And then we're going to give it some members. Now, in terms of this bracket style, you can see that IDE sometimes puts them on the wrong line. So I'm going to go with this, just spaces things out a little and adheres to Unreal's standards. So it's actually very simple. We're going to have two integers in here. One called bulls, and we're going to initialize it immediately to 0. Best with structs, keep it simple and don't worry about constructors and things. So it's basically the same as saying class bull cow count, but we don't need to say public because everything's public by default. It's a bit convoluted to start making things private. Why not use a class? And we're not going to have any methods in here. Now the only thing is I want to use int32, so there's a new habit for you since we made the substitution. So int32, a 32-bit integer for bulls, and a 32-bit integer for cows, both initialized to 0. That's it, bull cow count. Very simple. It contains two integers. Once we've done that, we can write the signature of our actual method here. So I won't overdo the comment yet. I'm going to make sure I get the signature right. So we're going to be returning a bull cow count. I'm going to call it submit guess for now, pending a better name if we find one. And we're going to take in an F string, starting to get used to our new types for Unreal. So I'm going to improve this comment, provide a method for counting bulls and cows and increasing the try number. That's fine. I'm just going to say counts, just to make it shorter, bulls and cows, and increases try number. And I'm also going to say that this method assumes, or probably in the implementation, I'm going to say it assumes, why not here? Assuming valid guess. So it assumes that a valid guess comes into this method. All right, so that's it. We have a submit guess signature there. Let's go ahead and define submit guess. So you go quick actions and then create definition and then go over to the game CPP file. Fantastic news. Okay, here we are. So before we do anything, let's pseudocode this before we even start. So what are we going to do? Well, as soon as we get in here, we've received a valid guess. Let's outline what this does. So receives a valid guess increments. Okay, so it turns out I can't spell increments, but this is a post edit, and I'm afraid we're stuck with it till the end of the section now. So apologies, and I know it should be an E in the middle there. Turn and returns count. Okay, slightly doubling up on our work here. So if you want to get rid of this in the header file, you can, to keep the header file tight and clean like that. And we can focus on the comment being just here in the implementation. By the way, back at the header file, when this says to make a more rich return value, this is the sort of thing I'm talking about. This is a richer return value than just a single integer. We'll be doing a similar thing here, but we'll actually be using an enumeration. Okay, so we have a richer return type. Let's see what this guy is going to do. It's going to increment the turn number. Don't do it yet. Okay, just stay at this level. What else are we going to do? Well, we're going to need to set up a return structure. We're going to need to set up a return variable, aren't we? We're going to need to declare ourselves an instance of this bull cow count thing and stuff. Don't worry about how we do that yet. Then we're going to loop through all letters in the guess. And then for each letter, we're going to do some comparisons. So for each of those letters, I'm going to indent to represent that. You can indent in pseudocode. I'm going to see compare letters against all, or just against the hidden word. Okay, so we're going to increment the turn number, set up something to return, loop through all letters in the guess, and then compare letters against the hidden word one at a time. And then at the end, we're going to return the bool cow count. So that is the structure of our submit guess. Now, before I flesh it out, I want to make sure it still runs, that all the scaffolding code I've written is valid. It is, which is fantastic. All right, so now we're going to start actually implementing it. I'm going to help you a little bit, and then I'm going to ask you to mainly complete this loop. So firstly, how do we increment the turn number? Well, under the comment, just go ahead and think that it's my current try, because that's the member variable, the data inside this class, this current instance of the game, plus plus. That's another way of saying my current try equals my current try plus 1, but I won't bother writing that. Plus plus is a shortcut. So we increment the turn number. Fantastic. Now we need to set up a return variable. How are we going to do that? We say bool cow count because that's the type. We give it a name, bool cow count. And that's it for now. Okay, it's already going to have things initialized to 0. If you want to be good about this, you could say bool cow count dot bools equals 0. And you are, in this instance, as we're using a struct, allowed to access the members. But actually, there's no point, because if we look at how we've defined bool cow count, it automatically initializes to 0. Okay? If you wanted to know that from where you were, you could put a comment here. 2 integers initialized to 0. Or just say all values initialized to 0. If you make that comment ahead of the struct, look what happens here. When we say bool cow count and you hover over it, it says all values initialized to 0. So we can just call it bool cow count. Now, in terms of Unreal's naming standard, I don't really like this. I don't really like the fact that my line says bool cow count, bool cow count. If we were a lowercase standard, then we would say bool cow count, lowercase bool cow count. But some people find that more confusing. You could also consider using prefixes here. But we're just going to live with it. Again, I want you to read code like the compiler does. The compiler's saying the first thing I'm expecting here is a type, and then I'm expecting, after the type, the name of the variable. So we're just going to say bool cow count, bool cow count. Now, at this stage, we're going to need the hidden word. Let's go back to our header and think what we're doing about the hidden word. We already have a piece of data for it. No, we don't even. We don't even have a data for the hidden word. So we need to make a piece of data. Let's make it an F string, because it's inside here, and it's going to be something we may want to manipulate. F string my hidden word. So now we have a place to store the hidden word. Of course, I shouldn't have an equals. F string my hidden word is just declaring it. Now, we've added a new piece of data to this. Now we need to decide where are we going to initialize this hidden word. Well, in future versions of the game, we can have lots of different hidden words on subsequent plays. But for this version of the game, we're going to have a single hidden word. So I'm going to initialize it up in the reset method. But just before I do, I'm going to fix this error here, which is saying call of an object of a class type without blah blah. So what's the problem with return? I'm trying to return a function. I should just be returning bool cow count. So the brackets give it away. Let's remove the brackets, and then that error disappears. So here we are, and of course this hidden word is very much a magic word in the same way as 8 was a magic number. So we're going to use const. Now we're going to try const expression, because it is known at compile time, and let's see if this works. F string hidden word. Constants all in capitals like that, and I'm going to use planet this time. So this is where we're going to go to adjust our hidden word. Now, it's complaining. What's the problem? It says the const expression variable must have a literal type or a reference type. So we're not using reference types and pointers and references and stuff at the moment, and it's not a literal like a integer. So we can't use const expression. It's too strong here. So when that happens, drop back to the next strongest, which is just const. Okay, that's great. So we've got that. Then we're just going to say my hidden word equals hidden word. And hopefully by now you get that we're doing this to get into the good habit of declaring magic numbers and magic words and strings as constants, so that when there's a big load of code in between here, we don't get in trouble, and that we can easily access what we need to change in a single place. Okay, enough on that. We have our hidden word set up. Let's compile our code, see if it works. So what we're going to do in the next video is look at the length of the hidden word. Oh, I've spelt hidden wrong. Let's just fix that. Fantastic. See you soon.